Okay, example 4, very similar to example 3. Again, we have a rod and we have a pivot point. So the first thing you do is identify which forces are going to be turning it clockwise, which are going to be turning it anti-clockwise. So the one at the end, the 4 newtons, is pushing it up. It's not directly perpendicularly up, but it's still pushing it up, so it's going to have an effect of turning it anti-clockwise. The 6 newtons down here, again, you can see is anti-clockwise, and the 5 newtons up at the end will be clockwise. Right, that's clockwise direction. So again, I'm just going to start by just colour coding. Right, so I know what I'm doing. This is pink, pink, and we've got this blue one at the end. That can be my clockwise direction. So start off by resolving, finding each moment in that direction. So the first one, the distance is 3 and the force is 4, but we've got this 40 degrees. So again, we have to think of it as a perpendicular force. So to get from the 4 to the perpendicular line, I have to go away from the 40 degree angle. So we're going to have a distance of 3 times by 4, but adjusted with sine 40 because we've moved away from the angle. So 3 times 4 times sine 40 gives me 7.71 Newton meters. The second one, luckily, is perpendicular. This is 3 times 6. So this is 18 Newton meters. Then we go to the blue one. So we've got this one here, and we've got a distance of 3 meters and 1 meter, and this force is a 5 Newton, but it's 80 degrees, so again it's not perpendicular, so we have to put in the perpendicular, and we have to see that it's gone away from the 80 again. So it's 4 is the distance, 5 is the force, times sine 80. And again we can pop this in, 4 times 5 times sine 80, which gives us 19.7 Newton meters. So again, it wants us to find the resultant, so the overall effect of what happens. So the resultant, right, we can see that this time, I've not labelled which one's which, so let's just do that quickly. This is anti-clockwise and this is clockwise. Okay, so this time we can see the pink forces, the anti-clockwise forces, when we add them together are going to beat this one. So we know it's going to be moving anti-clockwise, and we've got 18 plus 7.71 there on the same side, but the 19.7 is opposing. So we pop that into the calculator, 18 plus 7.71 minus 19.7, which gives us 6.01 Newton meters, and we must include the direction, right? That's the whole point. It's no good saying what the overall resultant moment is if we've not got that direction, because we want to know which way it's turning, and it's going to turn anti-clockwise.